that I've accumulated over the years, over this very same material. So, what do we need to look at? Some of them on Schoology, not all. I don't have answers worked out for all of them, but some of them on Schoology. Any answers I have?
Can we go over the question that says the price of chicken sandwiches in the cafeteria was $4.25. The price of $3.75 was the decrease.
Okay, is that
On this.
okay? So it's on. I don't know if you call it the front or the back, but it's the front or the back of the packet that I gave you. And the price was $4.25 last year, and now it is $3.75, and we want to find the percent decrease. How do we find the percentage change? What do we do to find the percentage change? It's the difference over the original, yep. So what's the difference in price? 50 cents? And the original price was 4.25, so we'll just type that in on our calculator. 0.5 divided by 4.25, and it's about what, 11.8%. So in other words, the price went down 11.8%. Yeah?
Can we do number 3 on the front of that packet?
So the packet, so just flip the paper over. Number 3 says f of 4 is 6. What is f inverse of 6? Now, remember, this means inverse. That notation means inverse. What do inverses do? What is the entire concept of inverses is what? They switch x and y. So, when we say something like f of 4 equals 6, what we mean is, if x is 4, y is 6. Remember, function notation is f of x. So this is your x. Well, if this was the original point, then what would the inverse point have to be? 6 comma 4, right? So if you put 6 into the inverse, you better get your 4 back again, because that's what inverses do. Okay? What else? Good question. What else that we need to clear up? Do not sit there and stare at me, people. We got a lot of math, and I'll just plow ahead. I'll do chapter 2 today. I don't care. I want to give you an opportunity to ask your questions. Amanda.
On the extra practice 1.5 through 1.7, number 3, C, letter C.
All right, so this is a graphing problem. And so I have my original picture. All right, so my original picture looks like this. All right, so this is f of x. Now I am going to graph negative f of 1/3 x. Well, I don't stand a chance unless I know my rules. I have got to know what impact a negative out here has. What impact does a negative out here have? Upside down, right? Technically, it's a reflection across the x-axis, but basically, it's just flipping me upside down. Oh, Nyla, I think I kept, what, you're here. I think I kept some papers for you, but maybe not. Yeah, I did. I need to turn all these back too. I'll do that at lunchtime. Yeah, I kept all these for you. These are things I handed out yesterday. Okay. All right, so what does the 1/3 do? divides the width. Alright, so if I'm graphing this thing, two things are gonna happen. It's gonna turn upside down, so this triangle right here, which is going down, is now going to be going up. Now, it's going to go up the same amount, but its width is going to be divided by a third. Well, how wide is it to start with? 3. What is 3 divided by a third? 3 times 3, which is 9. So now I have the same triangle, but now it's 9 wide and still 3 tall. So it's upside down and 3 times as wide. Now, what about this triangle? Well, he's going to be going down, and instead of being 2 across, he is now going to be 6 across. Okay, and then likewise, this little triangle, he's also going to be 6 across. He's also going to be coming down, but he only comes down 1 because he's short. Okay? Alright, what else? Peter?
Number 6 on the front. Or just front.
Number 6 says the retail price of a Goodwill jumper is $5. If the jumper's on sale for 65% off, and there's a 7% sales tax, how much will I pay for the jumper? So, the initial price of the jumper is $5, but we're gonna make a couple of adjustments to that. Each adjustment is going to be a multiplication. So if it's 65% off, then that's 1 minus 0.65. In other words, I am paying 35% of that. I'm not paying 65%. So since it's a discount, it's 100 minus 65. 1 minus 0.65. Now what about tax? Tax I have to add on, right? So that's going to be 1 plus 0.07 or 1.07. So if I type that into my calculator, I will get the right answer. Oh, looks like I'm going to pay $1.87 for that jumper. The one under that says, consider the function described by x equals root t and y equals t minus 3. What do we call these? What are these called? Parametric equations. Write an equation of the single rectangular equation described by these equations. So, what that means is, somehow, put them together, get rid of the t's, have one equation that has an x and a y in it. That's all. That's what we need to do. We need to somehow combine them. So you can either substitute or eliminate. Given that radical, I guess we could eliminate, or we could substitute either one, doesn't matter. If I square both sides of this, could I do elimination, eliminate the t's if I squared both sides? Now could I eliminate the t's? I'll have to multiply one of them by a negative. So x squared minus y equals 3. Now, that's how many equations? How many equations is that? 1. It's got the rectangular variables, x and y. Cartesian variables, and there's no t. So, there you go. Now, you could write that equation in different ways. For example, somebody else might say, well, y plus 3 equals t. And we could take that and put it in there. So x equals the square root of y plus 3. Now that's a different form of this equation, because if I square both sides, aren't these two equations the same? So some people who want to do substitution can do it that way. I did elimination, it came out like this, doesn't make any difference. Somehow have one equation and no t. And you're gonna accomplish that by either substituting or eliminating every time, whatever works for you. Okay? All right, what else?
Can we find the domain and range of that?
Of this one?
Yeah.
Yep, we can. Now, I'm gonna go back to, this is a complicated problem, but we can do that. So, if I look at my original equations, that's what I'm doing, we're right back to the beginning. Domain and range don't involve t. Domain and range involve x and y. But x and y are generated by t's. So whatever t I put in here, what can you tell me about this number x? It's going to be positive, right? So whatever is happening, my domain is going to be bigger than 0. So my domain is 0 to infinity. Because no matter what I plug in for t, x is going to turn out positive, right? Now, x is some positive number, t can be anything. T can be anything over here. But t, in order to do this problem, t had to be bigger than 0, right? So this t has to be bigger than 0, which means y is going to turn out what? Bigger than or equal to -3? Because the smallest t that I can use in this problem is 0. And if I put 0 in here, my y is -3. So my smallest y is -3, so my range is that. That's a complicated problem, but that's the process that you would think through it with.
Number 8 on this side, it's the solution.
On the what side?
Uh,
What does it say at the top?
says-
It's the second half of this. Okay, so it's the page that's only got 3 problems on it. Which one am I doing?
Number 8.
Number 8 is a mixture problem. All right, what is our setup for a mixture problem?
9% plus 1% equals.
Okay, so amount times percent plus amount times percent equals amount times percent. Guaranteed test question. All right, so I've got these 6 things, 3 amounts and 3 corresponding percentages. So I'm gonna put them in, let's see, so I got 73%, 0.73. I got 34%, and I'm gonna get 60%. All right, everybody got that? How many ounces, it seems like all of these problems start with that, how many ounces should be mixed with 20 ounces of 34 to get a 60% solution? Well, I'd love to solve this equation, but I can't until I fill in this. So think about what's happening. That's an amount. Where's that amount coming from? These two added together? So doesn't it make sense that this would be 20 plus x or x plus 20? And now you just have an equation to solve. So 0.73 373x plus 6.8, I'm gonna have to double check that just to make sure. And this is gonna be 12 plus 0.6. Alright, so then solving the regular equation, so 0.13x equals 5.2. Should you get 40?
Yeah.
You don't usually work out that nicely, I must have taken this from a book somewhere. Yep, 40, and that would be 40 ounces. Nine, cylinder. You know what a cylinder looks like? Has a 15-inch diameter, which means the radius is 7.5. All of our formulas involve radii, not diameter, so I'm gonna go ahead and just put 7.5. The water in the tank is 20 inches deep. If the drain is open, water leaves the tank at a rate of 2.5, I'm losing 2.5 cubic inches per minute. Write an expression for the volume of water in the tank T minutes after the drain is open. Okay, so stop and think about this for a second. Before I opened the drain, could I find the volume of the water? The original volume of water? Yes. The original volume of water is pi r squared h. That's this volume of the cylinder. R squared is 7.5 squared. And the height of the water was 20. So I'm gonna go ahead and figure this out. So 7.5 squared times 20. So that's 1125 pi cubic inches. Everything's inches. Okay, now that's how much water's in the tank right now. Okay? So then I open the drain and water starts coming out 2.5 cubic inches every minute. So if I said to you, what is the volume after 1 minute? Wouldn't you just take that number and subtract 2.5? And if I said 2 minutes, you'd take that number and subtract 5? Well, what if I said T minutes? You just take this number and subtract 2.5 T. That's how much water's in the tank after 2 minutes. Four. Okay, so 4 on that same page, the previous page, 4 in that same exercise, says, okay, there's my original picture that I had up there a minute ago. And I've done some stuff to it, and I've gotten this picture. So let's just in words make a list. What happened? How did we get from the picture in 3 to the picture in 4? What happened? Meg?
We had an absolute value around the whole, like the X and the parentheses, instead of just the X, like there was some absolute value.
Okay, to get from 3 to 4?
Yeah.
Okay, I can't have an absolute value because if I had an absolute value of the whole problem, it would be bottoms up and there would be nothing on the bottom. If I had an absolute value around just X, it would be mirrored on both sides, right? So I don't think there's an absolute value in here.
There's a
What is that, Meg?
negative X.
Okay, so there's a negative someplace because this picture has flip-flop. And it flip-flopped this way? Okay, so it has a sideways flip. Alright, what else has happened? We're gonna write an equation that reflects that. But what else has happened? It's flipped sideways and
It's up to.
it's up to. So if you take that original picture, flip it sideways and lift it up to, do you get what we have in number 4?
Yeah.
Alright, so what does the equation look like? Y equals F, it's gonna have some stuff here. So what do I need? If it's a sideways flip, negative X. If it's up to plus 2, there's the equation that would accomplish that move. Okay?
What happens if you put a negative in between the x and the parentheses? What does that do again?
Lose your left and right. X minus 2 would leave you left
Oh,
and
no,
right.
like before, like f minus parentheses and the x.
This is, you mean out here?
After the x. Add those f.
Well, that would just be this way factored out, but we've never done that. Okay, Meg,
Maybe number 5 right below it.
right below it, describe in words the transformations required to change this into this. Okay, we did this yesterday. Anybody remember doing this yesterday? Not this exact problem, but one like this.
Yeah.
So we looked at it graphically, that seemed to be easy for everyone. So this is what shape? Parabola. Move 2 units to the left and 4 down. So here's this parabola at -2, -4. Everybody good with that? Now what about this one? This one is 3 right up 1 and upside down. So describe the transformations in words. Okay, well one thing we have to do is flip it upside down, right? So that's one of the transformations. It's gotta be flipped upside down. Now it's gotta be moved from here to here. So look at your exit. It's going to the right, obviously. How many places to the right is this gonna have to be moved? 5. So you're gonna move it 5 units to the right. And then it's gotta go up. Oh, it's also going up 5, isn't it? And it's going to go 5 units up. So if you take this parabola, move it over 5, up 5, and turn it upside down, you'll get that one, right? Okay. Describe it in words. All right, one more. What else?
Can you do this one on the quiz?
Hand it to me.
The bottom.
Okay, so the original picture was over 2 up 4. This is the original picture, and then 1, 2, 3, over 3, down 2. All right. So on one of the quizzes, this was your original picture, and then we are graphing -2f of x minus 1. All right. Okay, so what all's happening? Let's make a list here. What's this doing? Upside down. What's this doing? Twice as tall. Multiplies height by 2. And what's this doing? 1 to the right. Now that is a lot to keep track of. So I think I'll do it in steps. So I'm gonna take everything and move it 1 unit to the right. So if I do that, everything 1 unit to the right, it means my triangle is starting here. Alright, so there's my triangle, and then my other one's gonna start here. there's my triangle, move one unit to the right. Now I gotta turn them upside down and make them twice as tall. Alright, so how tall is this triangle? 2. So I'm gonna turn him upside down, but instead of going down 2, now he's gonna go up 4. The original, or the main triangle there, went up 4. So now he's gonna go down 8. So that should be it. Alright, okay, time for lunch, everyone's back in their seats at 49. If nobody has a question, then we're moving on, chapter 2.